All right, here's some data for us to try out. We want to find the correlation coefficient R for the data in the table, and then figure out if R is statistically significant. If it is, then we want to go ahead and write down the best fit equation for the linear regression. Okay, so we need to enter all this data into the calculator and then find R, decide if it's significant. If it is significant, then we write out the equation. So first thing I want to do is clear the data, and to do that I do second data, slide over to clear data, push enter, and then second data. It's already on 2var, so that's good. Oops. 2var, that's good. And then push data, and then I'm going to put in 22, go down and put in the 401. That's one data pair, and then I do the next data pair. Remember to mark it so you know which ones you've done so you don't get lost. And so I've looked through my table and I counted 20 data points, and on my calculator I'm showing y sub 20, so that looks good. And then I'm scrolling back up through and I'm looking for 4-digit and then 2-digit, because that's what I saw as I was entering the data. And so I'm double checking that I didn't misenter. Okay, so it looks like all my data is there. Now I am noticing that we are talking about how long the baby was in the womb, the gestational age in weeks, so the number of weeks. Remember, 40 weeks is about the average length of time to have a baby. And here we have age for birth weight and gestational age for baby boys, and then here's the weight of the babies in grams. So there we have a bunch of weights. You can see they're getting bigger and bigger the longer that the mother is able to keep the baby in the womb, or the longer the baby decides to stay. Sometimes it's not the mother's choice at all. And then stat-var, calc, and then push the left arrow. There's my R. Whoa. So my R is 0.9319. The next digit's a 1, so I'm going to stop there. I want to see if it's statistically significant, and it doesn't say what alpha to use, what level of significance, so I'll just use 0.05, and then I'll also look at 0.01 because it might be significant at both levels because it's a really high value. So it's up at the top of this page. No? There we go. So I had 20 in my sample, and it looks like at either significance level, this one is significant because 0.444 and 0.561, our 0.9319 is much higher. So it is significant at the 0.01 level. Okay, so we have statistical significance for the correlation. We also know, because it's a positive number, that it is a positive correlation. So if I were to plot this, that it would be going something like that. And then I want to, if it is significant, which it was, determine the best fit equation for the linear regression. So what I need to do is write out y hat equals, and then remember it's ax plus b. So I'll just like write y hat equals, and then I scroll over to find my a, and that was 187.248 x plus, and then my b, whoops, needed to be minus because I have a negative b, so I'll put a minus here, and then it's 4020.806. And this is going to give us, if I plug in, remember my x's, I want you to write these. My x's are the gestational age, weeks of gestation, and my y hat is going to be the birth weight. And it's in grams. Now with these three pieces of information, I can make predictions, and I can now with these three pieces of information, I can use this regression equation to make predictions for different babies that are in the same interval. Use the regression equation to predict the weight of a baby boy if he's born after 40 complete weeks of gestation. What I want to do then is say my x is 40, and then I will plug it into my equation. My y hat is 187.248 times that 40 minus 4020.806. Now there's a sneaky way to do this on my calculator. I can just go back to the A, and I have the 187.248 with the rest of the decimals, and I can just say times 40 and then plus, and then I can go back to StatVar, scroll back over to the B and push equals, and it's going to do AX plus B. It's beautiful. So you can do that, and if I push enter, then what I'm going to get is y hat equals 3469.116, and this was grams for a boy born at 40 weeks. Okay, I want to show you that one more time without using the fancy AX plus B, because some of you might not like that method very much. So let's start over on that, and I will do 187.248 times 40, and I get 7489.92, and then I will just subtract off the 4020.806 and push equals, and I get 3469.114. So with my rounding that I did here, I'm going to be off a slight bit from those exact values that were sitting on my calculator. I'm okay with that. You probably will just want to round a little less, like 3469.12, and be done. Well, that would come to 11, wouldn't it? I'm okay with that. Just kind of watch what is happening on Hawks and how many decimal places they want you to round to. If they want you to round to the nearest millionth, then you should round your starting values to, say, 8 decimal places, just to be sure that you'll be correct to the decimal place that they're talking about. So for instance, we rounded to 3 decimal places here, so my answer was correct to 1 decimal place. So go 2 more than whatever you need to round to.